Alright, so for our first lesson in calculus, we'll answer a very basic but a very important question. Namely, what is a derivative? Now, I'm quite surprised that in a lot of calculus courses, they don't really outright go out and say what derivative is. They'll just expect you to keep on learning along as you go, but I feel that, especially for calculus, learning what a derivative is important to understanding calculus as a whole. So in layman's terms, what is a derivative? Well, a derivative is simply a rate of change. What we mean by rate of change is that, well, let's say we have a function. Let's use a ruler for preciseness, or rather for straight lines. Let's say we have a function, just a very simple function, y equals x. Now, what we mean by rate of change is, okay, so what's the slope of this line? The answer to that is just 1. So, derivative of that, dy dx, would be just 1. That's very simple for linear functions. And we can really find the derivative of a linear function. But you know, calculus isn't all about linear functions. So let's try another more common function. This is a quadratic function, of course. Y equals x squared. What's the rate of change of that? Now, what we mean by rate of change is, well, take a point, for example, this point over here. Now, and draw us a line, a tangent to that particular point. What that tangent line means, or rather what the slope of that tangent line means, is that at that particular point of this particular function, this function at that point technically has a slope or rate of change of the slope of the tangent line here. Now, another point over here, the vertex of this function. The slope of the tangent line is also 0. Now, why is that? It's because at this particular point in the quadratic function, well, the slope of that particular line is 0, and the function is just stagnant. It's not really going anywhere. Now take this, let's say, okay, I want to know the rate of change for the function at all the points. Alright, so with this little ruler, we can say, okay, at this point here, it's having this slope, and then slowly just follow the function. And at each individual tangent line, the slope mimics the curve of this function. So if we were to draw that out, okay, let's say we have x over here and we have dy dx, which is the slope of the tangent lines of that function y equals x squared at each of those points. So of course at 0 you have that, and you'll notice here, going back here, that from points here all the way to that vertex, which is at 0, 0, the slope of these tangent lines are getting less steep and are getting actually more positive at that rate. And as we go from the vertex to the other end of the curve, you see the line becoming much steeper. I mean, the slope of the tangent line is becoming much steeper and much more positive. Now, excuse the noise in the background. My mother is watching Ghost. Very great film. Unfortunately, it's not related to mathematics. So, from that visualization, we can see that the slope, each slope, if it were a function, would become this line. So, if the slopes of the tangent lines of each x value are graphed, this is what the derivative is. This is the derivative of this function. And appropriately, the derivative of the function y equals x squared is 2x. That's what a derivative is. It's simply the slopes of the tangent lines at every single point of the function. That's a derivative. In the next video, we'll talk about first principles and how people, before they had all these rules about calculus, how they acquired a derivative algebraically.